typed these up, just the examples, and that example handout is posted in Classroom. The only reason I did that is so that you're not trying to frantically copy down the problem when I put it up here. So you might just make yourself a note at the top of your paper that the examples are typed in Classroom, so that if you're wanting to look back in your notes, you can pull up the actual problem there and you don't have to copy it down right now. Okay, there are certain steps, and this is on that handout I posted in Classroom, so whether or not you write that down is up to you. Certain steps that we have to go through when we are solving any of these equations. The first thing I'm going to ask you to do is identify the variable. I don't want to see an equation and not know what x stands for. Because a lot of times there might be different ways you could solve the problem. And if we have a more complicated problem with a couple unknowns, if you don't write down what you're solving for, at the end you're not going to know what you have. So you get a point for doing this. Even if nothing else that you do is right, if you write down x is the length, I will give you a point just for doing that. Vice versa, if you don't write it down, then you miss that point automatically. Second thing, express other unknowns in terms of the variable. At this point in our class, we do not know how to solve equations for multiple variables at a time. Okay, if I give you an equation with an x and a y in it, we don't know what to do with that. So we can only have one variable. So if there's multiple things we don't know, we have to put them in terms of that one variable, and that's all. Third thing, set up a model. That's the equation. Write some kind of equation. Then we will solve it and check our answer. I probably should have put a step 5 on here. My rule is if I give you a problem in words, you have to answer it in words, so answer with the sentence. So 2 easy points on every problem. If you identify your variable and you write a sentence at the end, you're guaranteed 2 points. Right? So here's our first example. Again, you don't have to copy it all down. It's example 1 on the handout that's posted in Classroom. If the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of each side of the original square. Find the dimensions of the original square. You guys know what to do now? Makes perfect sense, huh? Okay, that's what people do when they're like, the circle, I don't get it. They just read the problem like that and they're like, I don't know what to do. So the first thing I'm going to tell you is we are only going to read a sentence at a time and figure out what that means. So the length of each side of a square. Let's even just stop right there. What should I do? Draw a square. We know a square, that means every side is the same, right? Let's have a square. The length of each side is increased by 3 centimeters. So what did I do to my square? Made it bigger. Let's draw a second square. That's bigger. Now, I don't want to come in and say this is side X and this is side Y because that's 2 variables. We don't want 2 variables. So we back up. We didn't know the side of the original square. So if I call that X, it is increased by 3. So what does that mean? All right. We just did step 1 and step 2. We identified our variable. Whether you tell me in words or you draw a picture and label it, that counts. We put everything in terms of that same variable. Now we're ready to write an equation. So it says the perimeter. What is perimeter? Add up all the sides, distance around the outside. The perimeter of the new square. So this is my new one. So perimeter, I have to add those up. Now you could write x plus 3 plus x plus 3 plus x plus 3 plus x plus 3. Or what would be a shorter way of doing that? 4 times the x plus 3. So I don't care if you write it out or use that multiplication. So that's the perimeter of the new. Is, that magical word is, what does it tell me? Equals 40 centimeters more than, what does more than tell me? So 40 plus twice, what does twice mean? Times 2, so 2 times the length of each side of the original. This is my original, the length of the side was x. So there's my equation. And this is a pretty manageable equation for us to solve. We distribute the 4. Over my 2x. Again, the amount of work you show for solving this is up to you. You do not have to show me every single step. If I subtract my 12, divide by 2, so x is 14. All right, am I done? No. I told you if I give you something in words, you have to answer it in words. So look at your question. I want the dimensions of the original square. If I look at my picture, x was the side in the original square. The original square had sides 14 centimeters. Less scary than it looks to start with, hopefully. We can break it down, take one sentence at a time. We can do these. Let's keep practicing. A rental car company charges $20 per day and 30 cents per mile for renting a car. Janice rents a car for 3 days and her bill comes to $72. How many miles did she drive? Is this a problem where drawing a picture is going to help me? No. So we have to define our variable somehow. Let's do it in words then. So what's the thing I'm trying to find? The number of miles she drove. So pick your favorite letter. Let's go with X. So X is the number of miles driven. When you're trying to decide your variable, a good place to look is the question. I wanted how many miles, that's the thing we need to find. Okay, then we have to write some kind of equation. There's no other unknowns here, so we're jumping to the equation step. It says they charge $20 per day and 30 cents per mile. She rents the car for 3 days. So $20 per day, she rents it for 3 days. What would I do? So if I'm just talking about that fee per day, I have to take it times the number of days. And so we have to add in 30 cents per mile. Why does it have to be 0.3? Right, the 20 is the dollars, is the change. And the bill was $72. So now we solve. So we have 60 plus 23x equals 72. If anyone needs a calculator, you can come grab one there. Is it dead? And did you get 40? Okay, so we're not done. We have to write our sentence. The question was, how many miles? She drove 40 miles. The next one I have has a little more to it. I would like for everyone to read the problem on their own and see if they can draw a picture to match it. Before you try solving anything, we'll come back together and make sure we're all on the right track. So just take a minute and see how far you can get on your own. Al paints with watercolors on a sheet of paper 20 inches wide by 15 inches high. So if I start by drawing that. Alright, there's my piece of paper. This is 20 inches, this is 15 inches. He then places this sheet on a mat so that a uniformly wide strip of the mat shows all around the picture. What does that mean? He's taking this piece of paper and he's going to put a mat around it, except the mat is going to have the same amount showing along every part. So I need another rectangle behind this one. Hopefully you guys are better artists than I am. Some days I struggle to draw a straight line. Do I know how much of the mat is showing? No, so what should I call that? X. But I do know it's uniform. So it's the same on every side. The perimeter, we see this again. Perimeter is when we add up all the sides. When we did the square, we just took one side times 4. Can we do that now? No, it's a rectangle. Now, we have 4 sides and 2 of them are the same and the other 2 are the same, right? So we could do 2 times the length plus 2 times the width equals our perimeter of 102. Or you could write out all 4 sides. What is this length? We know from here until here, it's a distance of x. From here to here, it's a distance of 20. And from here to here, it's a distance of x. So altogether, how long is that side? 2x plus 20. Okay, this side, from here to here is x. From here to here is 15. From here to here is x. So altogether that side is 2 equation we can all solve. Distribute the 2. Subtract over our 70. Divided by 8. And x is 4. The question was, how wide is the strip of map? And if we look at our picture, the x was the amount of the map showing on each side, so 4 is the answer we need. And that is 4 inches wide on each side. Any questions on those problems? So those are what I consider like our geometry problems. Problems where we can draw a picture and label things to help us solve it. What I want to do next, we are going to get into a new type of problem that you have not solved before. And these are called mixture problems. So we'll start them today. We may pick up with these tomorrow. We'll just kind of see how far we go. So we'll do 1, maybe 2 examples of those today, and then we'll look at it tomorrow again. So my first example says, how much water should be added to 2 gallons of a pure antifreeze to obtain a solution that is 70% antifreeze? There are different ways of solving these problems. So I am going to show what is typically the most popular method. I've taught this a few times. I've kind of learned what works the best for people. But if what I show you doesn't work for you, tell me and I'll show you another way. Okay, there's several approaches we can take. In this, we have water. We're mixing it with antifreeze and we're getting a final solution. So there's a lot of different stuff going on. My strategy with these mixture problems is to organize everything in a table. Anytime we have a lot of information, we need some way to organize it, and the table is an excellent option. So on my table, my rows are going to be my things I'm mixing. So we are mixing water, we're mixing antifreeze, and I'm just going to call this the final mix here. So we're putting those 2 things together to get our final mix. If I'm trying to figure out, I'm going to need some columns here. I'm going to figure out what to put there. We've never done one of these before, so we don't have much to go on, but your problem kind of gives you some clues. If you look at your problem, look at the numbers that I've given you. I gave you 2 gallons, so we're going to need some column to put those gallons in. And I have a 70%, so I'm going to need a column for my percent. So what I usually call this is amount, percent, or concentration. Okay. And then so if I let's take a little second. So if I am making lemonade for my kid's birthday party, okay, and let's say I am going to add, I need 5 gallons of punch, and I want it to be 50% pure lemonade, pure lemon juice. How about that? So for my lemonade, I want 50% lemon juice. If I need 5 gallons total, how much lemon juice am I going to put in there? 2.5 gallons. 50% is half of it, right? So what we can do, the amount, my 5 gallons, times my percent, 0.5, that gives us the amount pure. You take 5 times 0.5, you get 2.5 gallons of pure lemon juice in there. This is going to be the formula that we use on these mixture problems. So now, we just have to read the problem and figure out where these numbers go. First thing I said was how much water. So I do not know how much water I have. So what would my amount of water be? X. Should be added to 2 gallons of pure antifreeze. So my amount of antifreeze was 2. To obtain a solution that is 70% antifreeze. So my final mix, what's my percent? Now, do I just want to put, how should we, if you put a percent in a problem, what should you change it to? Okay. We've got some gaps, but we can fill these in. If I'm mixing this up, let's say I poured in 3 gallons of water and 2 gallons of antifreeze. How much do I have altogether? 5. How'd you get that? Add them up. So if I put in X gallons of water and 2 gallons of antifreeze, how much is in my mix? X plus 2 or 2 plus X, either way. Is everybody with me there? If you go fill up your water bottle, what percent antifreeze is your water that you're getting? 0. I hope. I don't want any antifreeze in my water. Okay, this one was pure. If it's pure, what percent is it? 100. So what would I put here? 1. The hard part is done, guys. Because we have a formula to get this last column. It's amount times the percent or the concentration. So X times 0 is 0. 2 times 1. And then we have our 0.7 times X plus 2. You can go ahead and multiply that if you want. I'm just, for the sake of your notes, writing out what I'm doing. The nice thing about these tables is the equations kind of work themselves out. This final column is saying, okay, in my final mixture, I have 0 gallons of water and 2 gallons of antifreeze and this much in my mix. All you're going to do is add the things you're mixing to equal your total. So it's just going to be 0 plus 2 equals the 0.7 times X plus 2. So then we can solve that. If you go ahead and divide, you're going to get a nasty decimal, so I would prefer to just leave this in fraction form rather than rounding our answer. Did you guys get 6/7? So the question was, how much water? If I look, the amount of water was my X. So there must be 6/7 gallons of water. guys want to try one more of those, and then we'll stop for today. So last example for today. How many liters of a 25% antifreeze solution should be added to 5 liters of a 10% solution to obtain a 15% solution? There's a lot of percentages here, but it starts out the same. We're mixing things. So if we set up our table, across the top, my formula is the same. It's going to be the amount times the percent equals the amount pure. Your labels for your rows, you can call them whatever you want. You can call it 25%, 10%, 15%. You can call it the first, the second, and the total. I don't care. Whatever makes sense to you. Okay. One thing, without ever reading this problem, could you tell me if you just saw a 10%, a 15%, and a 25% in the problem, which one has to be the final? Okay, if I'm mixing two things, why?
Because like if you're mixing the 25 and 10, it's only going to make the 10 to 25, so making them.
Exactly. You have to mix your highest and lowest concentrations, and you'll always get something in between them. So if I gave you any 3%, you could tell me which one had to be the final mixture. If I said we have 21, 17, and 19, which one has to be my final mix? 19, I put them out of order on you. But the middle, the final mix, is the one that falls in between the others. So looking at this, I know that my final mix is the 15%. That is something that people struggle with sometimes, so I just wanted to point that out. So if we wanted, we could go ahead and put the 0.15 for the final mix. So it's your highest and your lowest that you put together. Okay, how many liters of a 25%? So I do not know the amount of 25, so that would be X. Should be added to 5 liters of a 10%. So my 10% is 5. So what would my mix be? Adding them together to get my total. That's all I need. Now we can just start multiplying. X times 0.25. 5 times 0.1, you can go ahead and multiply those if you want. I'm just writing it out to show you what I'm doing. And how do we write the equation from here? Right. 0.25x plus 0.5 equals the 0.15 times x plus 5. So then we can solve this equation. And you get x equals 2.5. Everybody get that? So the question was, how much of the 25% solution for me at all? We will continue with this stuff tomorrow. I am going to give you a few problems. Remember, every problem I expect you to define your variable, whether it's drawing a picture or writing it in words or setting up a table, and you have to answer in a sentence. So I'm giving you 4 problems to start with. Tomorrow, I am not collecting these. I'm going to do probably 3 examples and give you 4 more problems, and then all 8 problems will be due on Thursday then. Okay, so try all these. They're not going to be collected tomorrow. We're just going to add to it. And of course, if you need help, you can come see me before or after school or in advisory. Or send me an email.